In this video, we're going to be looking at graphing in standard form of quadratic functions. Quadratic functions in standard form are going to have be in the form of y equals ax squared plus bx plus c. When we graph this, we typically like to graph it using 5 points. So on this first one, I might just make an xy table. And then 1, 2, 3, 4, 5. And so a few things to kind of note before we sketch this first one by hand, just to kind of remind you what maybe a quadratic would end up looking like. So if I was to take my graphing calculator, and let's say I hit the y equals key. If I wanted to graph y equals x squared, x is next to the alpha key, so I would hit x, boop, hit x. The second power is above this log key. And if I hit the graph, you can see it would make almost like this U shape, right? We call that a parabola. If I did second and table, you can see that we have some repeated values on the y's. The x's just changed by 1. But once we get to 0, 0, we have those values begin to repeat. So for y equals x squared, our vertex is at 0, 0. And we like to make our vertex our middle point in our table if we're going to plot, because everything's kind of symmetrical around that. So I'm going to pick 1 and 2, maybe -1, -2. And if y is x squared equals x squared, it's like I'm substituting -2 in for x. So -2 squared would be a 4. -1 squared would be a 1. And then you would get those same repeated values. And then if you wanted to check it, you would get the same thing on the table. You can see I have same thing, -2, 4, 1, -1, 0, 0, and so forth. If I was to go ahead and plot this, I have 0, 0. We have 1, 1. And then the same point occurs on the other side. And then we also have 2, 4. So our one side would look something like this. And then if I repeated it, it actually would look the same on the other side. So we got our 1, 1, our 2, 4, and it looks something like this. All right. And it would be like a nice curve at the bottom. We also have what's called the vertex. So that's the highest or lowest point, or the minimum or the maximum. Our vertex for this would be 0, 0. So I'm going to write 0, 0 is our vertex. And you can see you have like symmetry on both sides. If you were asked for an axis of symmetry, that's the line that goes through the center. That's going to be a vertical line at x equals 0. Right? So when we graph this, again, having your graphing calculator is pretty helpful, because if you want to use that to generate your table of values, otherwise you would just substitute all those x values into x and get your y value back out. Okay? For question number 2, though, it might be a little trickier to find our vertex, right? Because it's not just like an x squared. So in standard form, when we need to calculate what this vertex is, or like how to find that point, we use our axis of symmetry formula, right? Which tells us our x value. That formula is going to be the opposite of b over 2 times a. And so what that tells us is that tells us our axis of symmetry, or essentially what the x value is of our vertex. And remembering a, b, and c are those numbers or values in front of our terms, or coefficients. So for number 2, we might calculate our axis of symmetry first. So I would do the opposite of b. B is -6 over 2 times 1. So that'd be 6 over 2, or 3. So then when I go ahead and do my table now, my middle value, the x value I know is going to be 3, right? So that tells me my middle value, that's essentially, if I did my vertex 2, that's the x value of my vertex. For the other values, I'm going to pick x values that are above and below that. So I might pick 4 and 5. I might pick 2 and 1. And now I'm going to see what the y values are for this. So you can do this one of two ways. The long way you can do this is you can take your function and substitute these values in. So I could put 1 in for x and get a value out for y. I could put 2 in for x, get a value out for y, and so forth. If you do have technology, though, it does make life a little easier, right? So if I was to go ahead and look at my function here, I have x squared minus 6x plus 10. I said my axis of symmetry or middle or vertex was 3. If I go now to my calculator, I could hit y equals. I can type in x squared, so x to the second, minus, I'm going to use the subtraction key, 6x plus 10. And then I'm going to hit second and table. So second and graph. And then if I look at it, my vertex, we said was 3. Well, the coordinates for that are actually 3, 1. And then I actually have my other points here. I see I have 1, 5, 2, 2, 3, 1, and so forth. So I can actually now, if I want to, I can go ahead and fill all that in. So I said my 3 value was 1, and I have a 2 and a 5. I know these repeat. And then I can go ahead and graph that out, right? So again, if you don't have a calculator, you can just substitute those values in. But again, if you do, it does save you a lot of time for just evaluating, because then, evaluating is kind of like a pre-algebra skill anyways. So 3, 1 is what I would plot first. And then I would have 4, 2, and then 2, 2, and then 5, 5. And then I would go ahead and plot it. So you can see a couple things with this. You can see it's symmetrical on both sides. We would say that this actually is considered opening up because the arrows face upwards towards infinity. And then that would be it. For the next two, it's essentially the same exact thing. So we would go ahead and calculate. If we want to evaluate by hand, we can, or we can use our graphing calculator. So if I go ahead and make a table for this one, I'm going to use my axis of symmetry. So the opposite of b over 2a. So b is negative 8 over 2 times negative 2. So when I go ahead and simplify that, I'm going to get 8 over negative 4 or negative 2. So the middle point in my table is going to be negative 2. We're then going to pick some above and below. And then again, if we want to evaluate by hand, we can, or we can use our graphing calculator. So if we go ahead and type that in, so negative 2x squared minus 8x minus 12, our table would produce for us, we would see that at negative 2, we actually get a negative 4. At -1, we get a -6, but we also get a -6 at -3, and then a -12. And now we would go ahead and graph that out. So -2, -4. We have here a -1, -6, a 0, -12, and then the same points repeat on the other side. All right, so this one we have a vertex at -2, -4, and you can see it opens downwards, right? It's actually not a coincidence. You can see our leading coefficient is negative, so that's going to affect the direction our graph opens. So it's going to open down, and you can see it's a little bit skinnier than what we've been seeing because that's a 2 that's in front. And then finally for the last one, same thing. I'm going to go ahead and when I set up my table, I want to know what my middle value is going to be. It tells me where to start because it doesn't always start at 0, 0 like we're seeing. So I'm going to take the opposite of 6 over 2, and that's a -1. That's -6 over -2. We get a +3. So when I start my table, 3 is my middle. I'm going to go above and below. And again, you can evaluate those all by hand by putting 1 in for x and getting a value back out for y. Or you can put that in a graphing, the y equals in your graphing calculator, and that's going to save you a little bit of time. Actually, quite a bit of time. And then when we put that in our table, I see that at 3, I actually have -2. And then at 4, I got -3. At 5, I got -6. And then the values repeat above. And then you would just plot it and be done. And this one also, also coincidentally opens down because the coefficient in front, or that value in front, is negative. And then our vertex would be 3, -2 is the vertex. And that'd be it.